Dear colleagues, hello everyone, and welcome to my talk on the ripple effect and resilience in supply chains, lessons from and thinking beyond the COVID-19 pandemic. My name is Dmitry Ivanov. I am professor of supply chain and operations management at Berlin School of Economics and Law. Thank you for inviting me to give this talk. I am looking forward to an interesting discussion with you. In this talk, we will discuss some fundamental theoretical constructs and practical applications of how to engineer and manage disruption-resistant supply chain networks in order to mitigate the ripple effects in the context of the COVID-19 pandemic and in general in the context of long-term supply chain crisis, pandemic-like long-term disruptions. In the first talk, we will collate and review the existing knowledge in modeling the ripple effect in supply chains at different pandemic stages. We will discuss the role of digital supply chain twins and platforms in managing resilience and viability at the times of super disruptions like a pandemic, and project the lessons learned during the COVID-19 pandemic on possible future stresses to supply chain. And in the second part of the talk, we will debate about possible extensions of the existing theories and practices of supply chain resilience toward viability. And I will present the viable supply chain model and associated concepts of structural dynamic control, intertwined supplier networks, and reconfigurable supply chains. We start with a definition. Supply chain resilience is the firm's capability to withstand, adapt, and recover from disruptions, to meet customer demand and ensure target performance. Recall that we defined disruption as an event which is not planned or anticipated and may affect the structure or dynamics of supply chain systems. Resilience, it's a kind of immune system in the supply chain. If you can recall the first part of our course, we extensively discussed on the analogy between immune systems of human beings and resilience in supply chains, right? And risk in supply chains can be considered as a kind of virus. So we need resilience in order to cope with risks, like immune system coping with viruses. The second terminology that we will use throughout the presentation is named ripple effect. So ripple effect is something which refers to disruption propagation and associated changes in the supply chain structures, demand fulfillment, as a consequence of a severe disruption. Right? So, this picture nicely illustrates the key idea of the ripple effect. If we have, say, a disruption at a second-tier supply in the supply chain in one region, and due to complexity and globalization of many supply chains, this disruption is difficult to localize. In most cases, disruptions are propagating downstream the supply chain, interrupting normal operations at subsequent echelons of the supply chain and reaching quite far away downstream, even towards assembly plants and markets. Right? So, and when dealing with the ripple effect, we usually analyze three areas: performance impact, right, to see how our main performance indicators like service level or annual sales are affected or would be affected by these changes, negative changes in the supply chain structure. What should we do in order to stabilize our inventory control policies, production ordering policies, a kind of process level analysis? And then what should we do at the structural level to recover the supply chain? So it is a multi-level analysis which includes network perspective, process perspective, and control perspective. So, and in order to understand ripple effect better, perhaps we can contrast it to the bullwhip effect, right? I think many of you are familiar with the bullwhip effect, which is propagation of a small variation of demand at a couple of retailers upstream the supply chain, resulting in even greater fluctuations in order quality and production quantity at manufacturing plants and suppliers. Bullwhip effect is usually considered as a kind of high frequency, low impact event, right? And ripple effect is different. Ripple effect is a kind of disruption risk, which is low frequency, high impact effect triggered by severe disruption in supply base or in demand. In order to understand the ripple effect better, we can consider it in the setting which compares the ripple effect and the bullwhip effect. To recap, the ripple effect occurs when a disruption, rather than remaining localized or being contained to one part of the supply chain, cascades downstream and impacts the performance of the entire network. The ripple effect refers to disruption risks, right? Low frequency, high impact. The bullwhip effect refers to operational risks, a high frequency, low impact. Bullwhip effect is triggered by some small variation of demand, like in stability analysis. And ripple effect is triggered by severe disruption in supply or demand, closer to robustness and resilience analysis. During the COVID-19 pandemic, supply chain networks have experienced tremendous structural dynamics. Despite high inventory and backup infrastructures, many supply chains have frequently demonstrated severe shortages, chaotic behaviors, and a high exposure to the ripple effect during shock events. The COVID-19 pandemic has been a stress test for supply chains and revealed their weak responsiveness to severe demand and supply shocks. Time delays, high coordination efforts, and long shortage periods have been seen during these adaptive transformations. Technological and process structures should also be changed when the firms repurpose their traditional operation. Closure of major global hubs led to redesigning of the logistics structure. Missing liquidity in supply chains entailed financial structure dynamics, an example by changing the contracting schemes in global networks. When looking at supply chain resilience management at pandemic times, one can try to triangulate different resilience management activities in distinguishing three major areas of decision making. The first area is predicting the impacts of a pandemic on supply chains. The second area is analyzing reaction of supply chains amid a pandemic. And the third area is exiting a pandemic and post-recovery control. When we look at WHO classification of pandemic stage, we can see that this classification structures the dynamics of a pandemic into 5 areas: anticipation, early detection, containment, control and mitigation, and elimination. And as such, we can nicely allocate 3 areas of resilience management at pandemic times across 5 pandemic stages proposed by WHO. The predicting the impacts of a pandemic on supply chains happens at the beginning, in anticipation stage and in the early detection stage, when it becomes clear that a pandemic is approaching, it's upcoming, and we should do something for supply chain adaptation. Then when we are in the middle of pandemic and we undergo containment stage and we start controlling pandemic and mitigate the pandemic, it's more about adapting of supply chains to the pandemic and analyzing reactions of supply chains through the pandemic. And when it comes to the mitigation of pandemic and elimination of pandemic, then we are concerned as resilience managers of exiting a pandemic and post-recovery control, which are also not trivial tasks. When observing firms' operations during the first year of the COVID-19 pandemic, we can see that redundancy part of resilience capabilities, for example, risk mitigation inventories, subcontracting capacities, backup supply, and transportation infrastructures, have not really helped firms since the disruption period was very long. For example, in automotive industry, many processes are organized just in time, and inventory was available for a period of about 30 days at maximum. Moreover, suppliers and factories have been located in different regions, subject to different timing of shutdowns and lockdowns due to governmental measures to control the pandemic. And as such, even the available inventory or available backup capacities were not always accessible for a longer period of time. More positive experiences have been done with agile capacities and data-driven, real-time monitoring and visibility systems, so using digital technology. Agile capacities have enabled firms to repurpose their supply chains and to do it very quickly. Luxury goods manufacturers, for example, have completely transformed their operations to manufacture urgently needed items during the COVID-19 outbreak in March 2020 and later on. Many firms repurposed, for example, their perfume and hair care factories to produce hand sanitizers. Many designer clothing factories repurposed their supply chains to produce masks, gloves, and non-surgical gowns. Similarly, many automotive firms shifted their production from cars to highly needed ventilators and hospital beds by collaborating with local manufacturers and healthcare systems. As such, one important observation I would like to stress at this point is that adaptation capabilities played the most important role in the successful management of supply chains under pandemic disruption as compared to the redundancy capabilities.
The pandemic context is very specific, and perhaps it should be named as supply chain crisis. So not just supply chain disruption, because disruption is an event by definition, right? And crisis is something which is characterized by deep uncertainty about both short-term situation and future, long-term future, right? And this novel context which came with the pandemic can be described as a supply chain crisis subject to some specific characteristics which make resilience analysis for pandemic settings a specific research topic. And differentiate it from, say, instantaneous disruptions like earthquake or fire, where we have instant impact at some single supply chain echelon, well, maybe with some possible cascading effects, ripple effects, and usually recovery for such instantaneous disruptions begins when the disruption is over, right? Pandemic
contexts like super disruption or crisis, it's very different. Right? First of all, it is a long-lasting crisis with hardly predictable scaling and uncertainty about both short-term and long-term future in the supply chain and its environment. So we have case of deep uncertainty, unknown. Right? The second specific feature is simultaneous disruptions in supply, demand, and logistics. Right? This is something which is specifically and very new and understudied, underexplored area in supply chain resilience and ripple effect research. Another specific which is also novel and motivates a lot of new research is that recovery is performed in the presence of a disruption or crisis and hardly predictable scaling of this crisis. So we have a setting with a coupling of supply chain dynamics and disruption dynamics. So the disruption becomes an exogenous system to the supply chain, and so two system dynamics are interacting with each other. This is underexplored setting. Next, simultaneous and or sequential openings and closures of supplies, facilities, and market. This is also something which we never experienced before, where at different times, simultaneously or with some time delays, at different echelons of supply chains, facilities, supplies, and markets are opening or closing, and they opening and closing again. So this is, of course, completely new and interesting, motivating setting. Fifth, response and recovery strategies should take into account crisis recurrence and possible setbacks. This should be considered, right? So we have first wave, then we have second wave, then we have third wave of the pandemic. So in between we have some more or less relaxed time, and these recurrent effects, recurrently repeating disruptions and crises, are particular features of this new supply chain crisis context. And last but not least, we should not forget about cascading effects of disruptions, the ripple effect, which became one of the major stressors to supply chain resilience through the pandemic times. The pandemic challenged many supply chains to high extent. One reason in understanding these shock events can be considered in a relative stability in demand and supply, which led to formation of crisis-free management mentality over several decades. Right, so this crisis-free management mentality resulted in beliefs in having risks and uncertainty under control, in management approaches based on long-term predictable planning and associated lean but rigid, inflexible network structures and quite rigid planning paradigms, right, instead of adaptable planning. All this stability was turned upside down during the COVID-19 pandemic, and the pandemic challenged supply chain management by a novel and distinct construct of order and chaos, of controllable and uncontrollable, rigid and fluid, fixed and adaptable, certain and uncertain. Right? During the pandemic, the societal mentality has been coined by the sense of crisis, and this is a huge change from well-organized, long-term planning, beliefs in having a risk and uncertainty under control, lean structures, high confidence in future, and beliefs in full observability and controllability. Right? Disruptions have been usually considered as some exceptional events. Through the pandemic, disruptions became a part of everyday decisions. Right? Continuous preparedness to disruptions and living in anticipation of disruptions and continuous change instead of long-term stability, developed an ability to adapt as a central supply chain management perspective throughout the pandemic times. Adaptability and survivability, meaning the viability, became a normal rather than an exceptional state. Operations research methods for coping with the ripple effect can be divided into three areas, which are network and complexity theories, mathematical optimization, and simulations optimization. Network and complexity theories include application of Bayesian networks, reliability theory, pattern nets, and Markov chains, and complex adaptive systems to ripple effect and resilience analysis. The mathematical optimization methods which have been used are mixed interlinear programming, stochastic, and robust optimization. In simulation, we can see papers which deal with ripple effect using agent-based simulations, discrete event simulation, and the system's dynamics. So we have recently published a paper which extensively deals with different methodologies and different technical issues of each of these methods and how it has been used for ripple effect analysis. That's why I will not go into detail now due to the limited time of the talk. And I refer to the paper indicated on this slide, where you can get much more details. Most interesting and most important now to me, each of the studies, each of this group can help deduce useful managerial outcomes. For example, the studies at the network level help supply chain managers to identify possible scenarios for disruption propagations of different severity, depending on the degree of risk aversion of supply chain management. These methods can also be used for stress testing of supply chain design prone to disruption risk propagation. And such methods can also be used for identification of critical suppliers and facilities. Finally, we can also apply network and complexity methods for adaptation of supply chain design, for example, using complex adaptive systems according to changes in the system environments. At the process level, we can provide to practitioners a lot of useful methods like stress testing of supply chain production distribution plans within some disrupted networks, analysis of different contingency and preparedness plans, and these methods can also help to select optimal recovery plans in the supply chains. And simulation studies can be used for analysis of disruption propagation in dynamics. They help understand impact of changes in production and inventory control, and understand different operational policies under disruptions, during the disruption period, and also in the post-recovery period, for example, to identify so-called disruption tails in the supply chain, which are very dangerous if we do not change inventory control policies in the post-recovery period. Well, this is one specific topic, and I would refer to literature with regard to disruption tails to understand this effect more detailed. I would like to summarize now some insights, some outcomes of this research without going into the details of the simulation, which are described very detailed in the paper, which is indicated in this slide. So what we have observed through the simulation of different scenarios, we looked at scenarios of different severity of a pandemic, if pandemic can be localized, say in one region, or pandemic propagates to different regions, resulting in lockdowns and shutdowns. We looked at different duration of lockdown periods, and we also looked at different timing of lockdown periods in different regions. So this created about 40 scenarios, and analysis of the supply chain performance reaction to these scenarios allowed us to identify. This idea of matching and bridging physical supply chain design and data, say digital supply chains, can find its practical implementation when using digital twins. A supply chain digital twins allows a transition from offline modeling of disruption to online data-driven decision-making support for supply chain resilience management. Supply chain digital twin, put simply, it is a computerized supply chain model in real time, so digital supply chain. The digital supply chain model, which at each point of time represents a physical supply chain with the actual transportation, inventory, demand, and capacity data. And such a digital twin can be used for planning, for disruptions, and also for reacting to disruption in terms of real-time control decision. In the digital supply chain, twin model-based decision-making support enables simulation of the supply chain dynamic behavior in case of a disruption. And in addition, if a disruption occurs, potential impacts on supply chain performance can be evaluated, and then recovery policies can be optimized. Data analytics is the primary driver of digital twin. Data analytics is used at the proactive stage for building realistic disruption scenarios based on some risk data about historical disruptions and other data like weather data, financial data, supplier reliability data, which can be obtained from ERP systems, for example. At the reactive stage, data analytics can be used for disruption identification and in real time using some feedback data from sensors, stress and tracking systems, and RFID. And then this data is transferred to simulation and optimization model, which through computations, which we already discussed previously, can allow analyzing of performance, which can then be transferred to business intelligence or ERP systems. Combination of simulation, optimization, and data analytics constitutes, therefore, a full stack of technologies to create a digital supply chain twin to improve resilience, a model that always represents the state of the network in real time. We now illustrate principles and data-driven disruption modeling on example of a digital supply chain twin developed with the use of any logistics software, which is a tool for model-based decision-making support in supply chains. A combination of simulation and optimization and data analytics is based on the mapping of risk data with geographical location in the supply chain structure. On one hand, we have disruption data coming from different digital sources, data about different disruptions. This data can be retrospective, which can be used for statistical analysis about previous disruption, and this data can also be real-time data, which is obtained through monitoring of supply chains. Disruption data is transferred to simulation and optimization models. In between, filtering of data happens using big data analytics and machine learning techniques. And then the disruptions are put into simulation models like disruptive events. If we use event simulation, discrete event simulation, all this data it's transferred to the constraint system of mixed integer linear programming models. And with this data, simulation optimizations models can compute optimal proactive resilient supply chain designs and also reactive recovery plan. As such, the retrospective data it's mostly used for prediction and analysis of possible disruptive scenarios, while real-time data is used for real-time control and deployment of reactive recovery plan. The results of the modeling it's transferred to ERP systems or BI tools for further extended performance analysis. Finally, if we generalize the insights from this case study, digital supply chain twins, like any logistics, are of utmost importance and value for stress testing and reviewing supply chain resilience. Right? So one can certainly look at creating some scenario, like COVID-19 pandemic or Suez Canal congestion in the supply chain, or any other short-term or long-term disruption scenarios. And then with the help of supply chain model, one can make a kind of stress testing of the existing supply chain, look at possible performance impact through simulations, and also consider analyze possible reaction recovery plans and select the most efficient, the most responsive one in terms of operations and operations performance, customer performance, and financial performance. So basically, digital twins are an ideal tool for stress testing and reviewing supply chain resilience. Another important area is viable supply chain. Supply chain viability, it's seen as the next direction, next step in resilience theory development. And the importance of this part of this area became evident through the COVID-19 pandemic times. So viability is seen as the ability of a supply chain to maintain itself and survive in a changing environment through a redesign of structures and replanning of performance. So a viable supply chain model is based on adaptable structural supply chain designs for supply-demand allocations and, most important, establishment of adaptive mechanisms for transition between different supply chain designs. Usually, before the pandemic, the companies have mostly focused on efficient or responsive supply chain design, right? And considered, for example, random uncertainty like demand fluctuation as a possible stressors to this design. Many companies have also utilized resilient supply chain designs as a response to natural disasters, for example, which considered some, resilience capabilities like risk inventory or capacity buffers or backup supplies. However, one element was missing, and this element became very evident through the pandemic, and this is survivable supply chain design. Through the pandemic, we have observed that the firms needed to repurpose their supply chain, to redesign supply base and logistics, to localize many processes. This level of survivability, it's something which became evident for the pandemic time, and now with all these three levels, agile, resilient, and survivable supply chain design, we can we can define a new kind of supply chain understanding, which is a viable supply chain model, which allows to survive, which allows to maintain operations continuity with regard to different stressors. Random stressors like demand fluctuations, and very severe, very deep uncertainty like natural disasters and even global pandemics, right? So that's more important to survive, to maintain business. And in order to maintain business, we need to ensure survivability of our supply chains. So this is something new which came from the pandemic times and which can be seen as a research direction, right? So this difference can be very nicely understood when we take example of a car. So why we are driving a car? We are driving a car in order to get faster to some destinations, right, at short lead time, in operational view. However, strategically, we are driving cars in order to stay mobile, right? And for example, a car can break down. So this is a disruption, right? Then we analyze what happened, assess impact of this disruption, and then we need to stabilize. So we are driving to a service station where our car will be repaired. So this is recovery. And then we get it back in an old or maybe even improved or equivalent stage. So this is classical resilience profile. However, what happens if a car cannot be repaired anymore? So in this case, we need to adapt structurally, right? We can start using public transportation, or we can buy a new car, but anyway, it will be new normal for us, right? It is not more about to returning back. It will be new normal for us, and we need to organize our operations as this new normal and recover performance after that. So this is what we understand under viability. So very close issue is to viability, it's intertwined supply network. Now, only a few cases supply chains can be clearly separated from each other. They are usually intersecting. Firms can change their behaviors, their roles, buyers and suppliers. The firms can be buyers and suppliers at the same time. And as such, if we look at the intertwined supply network as object of optimization, it makes sense to develop ecosystem view of the supply chain, right? For example, suppliers in automotive sector can be at the same time producers of wells for respirators. All right, so you have two intertwined supply networks where the same firm changes behaviors. So that's why I encourage to look at intertwined supply networks as an object for supply chain resilience management. Let us look at another important concept related to supply chain viability, which is multi-structural dynamics. Indeed, in real life, supply chains represent complex coordinated networks that operate in uncertain environments and are therefore exposed to different risks and disruptions. Notably, supply chain networks are composed on different structures which are interconnected. Right? In many cases, we understand supply chain only as organizational structure, as a network of firms which coordinate and integrate their activities from raw material suppliers to the customer. However, the existence of organizational structure is supported by many other structures which are interconnected with each other. And we can observe in the figure shown in the slide that multidimensional dynamic space is very important for understanding of supply chain resilience in terms of multi-structural dynamic systems. The main supply chain structures are product structure, the process structure, organizational structure, technological structure, logistics infrastructure, financial structure, and informational structure. We can also include, for example, energy structure in this figure as an additional one. Consider an example of importance of multistructural dynamics. During the COVID-19 pandemic, supply chain networks experienced tremendous structural dynamics. Despite high inventory and backup infrastructures, many supply chains have frequently demonstrated severe shortages, chaotic behaviors, and a high exposure to the ripple effect. During shock events, especially long-lasting events with drastically increased demands and supply, like COVID-19 pandemic, the consideration of multi-structural dynamics is of vital importance. For example, since many suppliers became unavailable due to lockdown measures and bankruptcies, firms had to adjust their organizational structures of supply networks along with the product structure, for example, repurposing of supply chain, to react to demand disruption. Technological and process structures should also be changed due to changes in organizational structure. An example, when the firms needed to change their supply chain to repurpose to production of completely new products. Through the pandemic, we have also seen disruptions in logistics infrastructure and also in financial infrastructure of supply chain, which had immediate and very tight connections to other structures. As such, the multi-structural dynamics notion is very important to manage supply chains and their adaptations. Dynamics, right? And to finalize this discussion, another newly emerged framework is the reconfigurable supply chain, which looks at advanced utilization of digital technologies, sustainability, resilience, and efficiency in designing and managing the supply chain network. Right? So reconfigurability is an important part of supply chain viability. And at the very end of our lecture, let us focus on three perspectives of supply chain viability. These perspectives are micro perspective, meso perspective, and micro perspective. A micro perspective is closely related to what we usually consider in supply chain resilience. It is related to short-term disruption, to instant disruptions, like, for example, a fire or earthquake. And in that case, the coping strategies are related to recovery and firms' resilience. Then we look at the meso perspective, which considers a medium-term horizon. One example is a pandemic. Right? The coping strategy for meso perspective are related to adaptation and supply chain survivability. And then we should also look at micro perspective. It is a long-term, very long-term horizon, much longer as a pandemic. One example is the climate change. The climate change represents one of the major challenges for the humanity in the 21st century. And so the supply chain viability is tightly related to the climate changes. And numerous studies forecast radical changes in climate by 2050, which will directly and explicitly influence our supply chain. Because of the climate change, many supply chain activities in manufacturing and logistics could become restricted or even impossible for long periods of time at many locations worldwide due to increasing severity and duration of extreme weather conditions. Right? In these settings, global supply chain management would not be focused on efficient production only, but rather need to ensure the existence, the survivability of production and logistics as such, providing society with goods and services through dynamic, reconfigurable supply chain networks. As such, the climate change takes the micro perspective of supply chain viability that it's coped by adaptation and multi-structural network transformations. An example using reconfigurable supplier base, reconfigurable manufacturing base, reconfigurable logistics base, and so forming and structurally reconfigurable supply chain networks. For example, if some regions in the world would be affected by severe weather disruptions, it's likely that all suppliers in this region would be disrupted, and all manufacturers. As such, to maintain supply chain continuity, the firms would obviously need established backup supplier bases, and not only single suppliers, somewhere else in the world, in order to situationally reconfigure supply chain flows to this backup supplier base. Smooth and efficient adaptations will be possible using both preparedness plans and digital technology. And finally, I would like to note that supply chains themselves can mediate the severe impacts of the climate change by developing sustainable practices and so contributing to reducing emissions and wastes of natural resources. We can think of energy-efficient manufacturing, sustainable logistics, and flexible, dynamically reconfigurable supply chains with situational networking of resources of distributed suppliers, manufacturing, and logistics, which can be seen as directions to match resilience, viability, and sustainability across micro, meso, and micro perspectives. All this created discussions and concrete measures about rethinking and reinventing supply chain management in the post-pandemic world. Indeed, supply chains are confronted with several challenges. They are stemming from four major dimensions, as illustrated on this slide: nature, business, market, and government. Right? Supply chains are continuously exposed to some natural disasters, which happen continuously. They are also exposed to epidemics and pandemics, which are not so frequent events. And strategically, on the long-term scale, supply chains are exposed to the climate change. Right? There are some sentiments that different regions in the world can be available for production and logistics activities in future only during some period of times, right? And as such, there are needs and concerns about how to design and manage supply chains if several regions can be unavailable maybe for many weeks or even many months, right? On the other hand, there are some market challenges, both positive and negatives, right? So negative challenges like, for example, financial crisis, which can become a huge disruption to supply chains, and positive challenges like digital platforms development, which create new opportunities for supply chain management stemming from the market. Business as the next dimension in this framework is driving digital technology and platform economy in the center of management activities, and this has direct implication on supply chain management and creating a new understanding of design and management supply chain networks and leading to rethinking and reinventing supply chain management. And the fourth dimension is government, sustainable development goals, for example, or some acute pandemic control measures. All this has direct implications and influences the supply chain. And in this context, a number of novel questions arise. For example, what is the role of adaptability in resilience and viability of supply chains, and how to implement inherent adaptability while maintaining profitability? This question means adaptability, resilience, viability should become a normal for supply chains it is not something, as adaptability, it's not something which we utilize only in the case of disruption, only in the event of some exceptional situation. Right? So everyday activities, business as usual scenarios can be organized using inherent adaptability in mind, while of course maintaining and improving profitability. Another question is, should we change from long-term planning to situational reaction paradigm, or can we, or do we believe that we can control uncontrollable? Right? So most of the existing supply chain strategies and management tools presume some long-term stability, and even if disruptions happen, it is frequently taken for granted that there is always a way to return to normal. Right? Pandemic has shown some different context. Another question, is planning under chaotic conditions helpful or counterproductive? Right? So usually all supply chain management activities are based on planning. Long-term planning, mid-term or short-term planning. And as we know, planning is as good as the certainty of the system. Each additional uncertainty makes it more difficult to implement planning. Right? And as such, especially under such chaotic conditions like a pandemic, the existing planning methods, which were not too adaptable and not too reactive, have not always performed well. So, dear colleagues, to summarize this presentation, we were mostly looking at risks, resilience, and ripple effects, which are major determinants and major stressors to supply chains, and seem to be very important for new normal, which can be increasingly shaped by uncertainty. The existing theory offers a large variety of methods to support supply chain adaptations and reconfigurations, methods at the network level, mathematical optimization level, and simulation levels. However, the pandemic is definitely a very new and very specific type of supply chain risk and disruption, say super disruption, which clearly shows that even if resilience can be costly, a missing resilience can be fatal. And finally, we have identified future research areas like advanced utilization of digital technologies and digital twins for managing supply chain resilience. Then we looked at supply chain viability and intertwined supply networks, which motivate us to think beyond a narrowed resilience understanding as just a recovery of some critical capabilities or economic performances, and organizing debates toward long-term viability and more complex supply chain networks. In this sense, there are relevant frameworks like reconfigurable supply chain or LSN supply chain framework. We have not considered it much in presentation, but mostly LSN means lean resilience. Right? So organizing resilience in an efficient way and using resilience for value creation. All right. And very relevant topic to viability is open system view of resilience, and all this creates a very exciting, very motivating, insightful agenda for future development of supply chain resilience theory and practice to create knowledge about super long disruptions. So thank you very much, dear colleagues, for your attention. Now I look forward to discussing with you questions about this topic.